Hello students, today I am going to revise with you the full NCERT, all the formulas that you require, okay, from chapter 1 to the end. So it will be a good revision for you. Take a paper and pen along with you and start revising with me. You will be able to revise all the formulas from chapter 1. So this is going to be helpful for you for your upcoming pre-boards as well as your board examinations. So this is the PDF of the latest maths textbook. Kindly do not refer to old textbooks as it has a lot of extra syllabus. So this is the deleted syllabus as per 2022 that I am doing. Last year it was rationalized. So this is the rationalized book. That's why you find this rationalized content 23-24 here, right? So we are going to start with the first chapter here, and the first chapter here is real numbers. And in real numbers, as far as formula is concerned, here there is finding of HCF and LCM. So finding an LCM, there is a prime factorization method, yes, but there is only one formula, and that formula is HCF into LCM is product of the numbers. So here we have our first formula in chapter 1, that is HCF into LCM. So formula number 1, in chapter 1, we have only one formula, that is HCF multiplied by the LCM is product of the numbers. A and B are two numbers. So HCF into LCM is product of the numbers. So if you are knowing any three, suppose you want to find out one number, HCF and LCM is given, and one number is given, you can find the second number, right? So this is the only formula in this chapter 1, right? So I hope this is clear. HCF into LCM is product of the numbers. Only one formula you have to do here. Rest is all proving number as rational, irrational, and so on. Next we come to chapter number 2, that is polynomials. So let me take out polynomials. So in the chapter polynomials, we have the first formula, that is sum of roots, and second formula is product of roots. So in chapter 2, we know that the roots of a polynomial are represented by alpha and beta, and the general equation is ax square plus bx plus c. If you are taking a polynomial, ax square plus bx plus c here, then alpha plus beta is minus b by a and alpha beta is c by a. This will also useful in quadratic equation. Sum of roots, alpha plus beta is minus b by a, and product of roots is c by a. So if you are having verification question, then we'll have to use this. Alpha plus beta is minus b by a and alpha beta is c by a. So in the first exercise, there is no formula. In the second exercise, they have asked us to verify the zeros obtained with the coefficient of the polynomial. So let me take out the second exercise. So here we are having the second exercise. In the second exercise, we have this question: find the zeros of the polynomial and verify the relation between zeros and coefficients. So here I am going to use this formula, alpha plus beta, that is sum of zeros, is minus b by a, this formula, and alpha beta is c by a. Now cubic polynomial was there earlier in the previous book, but now it is not there. They have given here in the summary, but there is no question based on this. So we have alpha beta gamma 0, alpha beta gamma as the zeros of the cubic polynomial. I am not discussing that, but because there is no question based on it. So again, question number chapter 1, there is only one formula here, right? And here in chapter 2, there is only one formula, two formulas. In fact, sum of roots is minus b by a, where b is the coefficient of x, and here we have alpha beta, that is the product of roots, is c by a, where c is the constant and a is the coefficient of x square, right? So we go on to chapter 3. So you see, first and second has got only one formula. In chapter number 3, again, we have only the conditions. If you look at the conditions, you know that there are two linear equations. A1x plus b1y is c1, and the second is a2x plus b2y is c2, right? We are having this. Now, the conditions, this we should know. What are the conditions? A1 by A2 is not equal to B1 by B2. If I have this A1 by A2 not equal to B1 by B2, I will compare the coefficients. If there is any sign, please make sure of that. Then this becomes a unique solution. Unique solution means when you solve, you will get a definite answer. And the graphical representation will be intersecting lines. So when you are doing a question and if A1 by A2 is not equal to B1 by B2, that is unique. Unique means it will be intersecting lines. If A1 by A2 is equal to B1 by B2 equal to C1 by C2, then this has infinite solutions. Infinite solutions. So when it is infinite, you will get two lines, one on top of the other, that is called coincident lines. These are coincident lines. A1 by A2 equal to B1 by B2 not equal to C1 by C2. The first two are equal but not equal to the third. This is no solution. In a no solution, you will get a case of parallel lines. Parallel lines do not intersect and therefore we will get parallel lines. So in chapter 3, this is important, knowing the conditions. A1 by A2 not equal to B1 by B2, unique. A1 by A2 equal to B1 by B2 equal to C1, all equal, infinite. Unique means it will intersect. Infinite means coincident lines and no solution will be parallel. These two are having solution, therefore it is called consistent. So sometimes question comes, are the equations consistent? So you'll have to apply this and check whether it is unique or infinite, and this is inconsistent. So that is what we need to do in chapter 3. Moving on to chapter 4. Now in chapter 4, this is quadratic equation. In quadratic equation, of course, I told you in polynomials, alpha plus beta minus b by a and alpha beta c by a, that will be there in this as well, because this is a quadratic equation. The highest power, that is the degree, will be 2. So here we have questions on identifying whether it's a quadratic. And here you also have quadratic formula. So there is one formula called the quadratic formula, which we know. So find the roots by factorization, that is by splitting the middle term and others. And here you find this formula to find nature of roots, and here you will have the formula of alpha and beta. So this has to be done in chapter number 4. So here we are going to do chapter 4, that is quadratic equation. In quadratic equation also, the first formula that we will do is to find out the value of the discriminant. Now discriminant, if you see, is represented by the formula b square minus 4ac. So here the question will be, what is the nature of the roots? So nature of the roots can be found by finding this discriminant. So this is very important. Discriminant is found by using b square minus 4ac. We know that quadratic equation is ax square plus bx plus c is 0. Discriminant is b square minus 4ac. Now, if the discriminant is greater than 0, then roots are real and distinct. Real and distinct means when I solve this, I'm going to get two answers. Quadratic, remember, will always have two answers. It will have two answers. Both of them will be distinct answers, 2, 3, 1 by 2, 1 by 5, like that, distinct. If discriminant is 0, then roots are going to be real and equal. Real and equal means you will get two answers, but both of them will be equal. So it will be 2, 2, 3, 3, like that. So here we are having real, here also real, but here you will get two different answers. Here you will get two same answers. If d is less than 0, then we will have unreal roots. If d is less than 0, unreal roots. Now, there is the quadratic formula by which we can find out the quadratic formula. You should know to find out the roots of a quadratic. Roots are alpha and beta. The formula is minus b plus root d by 2a. Now, first I'm going to find out d. If it is unreal, we will say unreal and not solved. If it is real, we will use quadratic formula to find the answer. So first answer is minus b plus root d by 2a. And the second answer minus b minus root d by 2a. So that's chapter number 4, quadratic formula. First find out the discriminant. After finding out the discriminant, you are going to use quadratic formula and find out the roots. Next, we come to chapter 5, that is arithmetic progressions. AP in short we refer. So we know that arithmetic progressions, the first number is represented by A or A1, second is A2, and it goes on up to AN. So you can have a series like this 1, 3, 5, 7, and the last number is AN. Now there are two formulas. The first formula is AN is A plus N minus 1D. This is the formula to find out the nth term. So A is the first number, D is the common difference, right? Common difference will be A2 minus A1. This is also one thing that we have to remember. Common difference is never A1 minus A2. It is A2 minus A1. So 3 minus 1 is 2. This is very important, especially when we have series like this. Some people do common difference is 5 minus 4. No, that will be 4 minus 5. So common difference is negative. That's why this arithmetic progression is decreasing. When the common difference is negative, the arithmetic progression, the numbers will keep on decreasing. Here you will find that the common difference is positive 2, that's why it's increasing. So the first formula is to find the nth term, A plus N minus 1D. So you want to find the 10th term. So we will say A10 is A plus 10 minus 1D. So A and D you will get from the series. A value is 1, common difference is 2. Put that, you will get the 10th term. So we can find 100th term, 500th term very easily with this. An is A plus N minus 1D. This is the first formula. Second formula is to find the sum of an arithmetic progression. You have numbers from 1 to 100 or 1 to 300. You want to find the sum of this. It will take a lot of time. But I'm going to use this formula n by 2, 2a plus n minus 1d. This is the formula to find sum of this. Sum of 1 to 300, n by 2, 2a plus n minus 1d. This will be the formula to find the sum of numbers from 1 to 300. So how many numbers are there? 300 numbers are there. A and D we can find from here and we get this. We can also use another formula, Sn equal to n by 2 a plus L. If I know the first number and the last number and the number of terms, I can also use this formula to find the sum of n terms. So these are the two formulas which we should know for sum, and this is one formula to find out the nth term, right? Both these formulas will take care of this chapter. Next, we have chapter 6, that is triangles. Now, triangles being a geometry chapter doesn't have any formulas. Of course, there is a theorem, that is the Thales theorem or the basic proportionality theorem. The proof of that has to be done. But as a formula, there is nothing. You have to know the basic proportionality theorem. Application of that will come. So we need to prove AD by DB is AE by EC. If DE is parallel to BC, then AD by DB is AE by EC. So you will get numericals based on this. So AD by DB is AE by EC. So this is one theorem, the basic proportionality theorem, which you have to know. The proof of this is given, and this is expected question. So kindly do the proof of this. The proof is given to us in the textbook. Kindly do this proof as given in the textbook. It is better that you use the same method used by Thales. There are many students who do by alternative methods. You can do alternative methods in problems, but it is better to use the theorems as given by the original mathematician as far as theorems is concerned. So Pythagoras theorem, Thales theorem, all this, it's important that we follow the same steps as given by the original mathematician. So this is the theorem that I was mentioning. Kindly do this theorem. This is very important examination point of view, because there's only one theorem now. Earlier there were 4 theorems. 3 has been deleted. There's only one theorem. So the chances of this coming is very high. Next, we come to the chapter 7, coordinate geometry. Now, in coordinate geometry, the first exercise deals with the distance formula to find the distance between 2 points. So now we are doing chapter 7. 6 was triangles. The coordinate geometry. So if I have 2 coordinates A and B, the coordinates of A is taken as x1, y1, coordinates of 2, x2, y2, and the distance between them is d. So the first formula that we have to use here is distance formula. How to find the distance between them? Distance is root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula by which we can find distance between 2 points. x2 minus x1 whole square, y2 minus y1 whole square. Take the root of that. This is distance formula. Second, you have the section formula. Now, what is the section formula? Whenever there is a question of ratio or you want to find out the ratio, then this is used. So the ratio is represented by m1, m2. The first coordinate is x1, y1. Coordinate of b is x2, y2. So this is x1, y1 and this is x2, y2, and you want to find out the ratio in which a point P divides this line AB. Okay, so whenever there's a question of ratio, please make sure that it is a question based on section formula. You want to find out this coordinate. So note down this formula. X is m1 x2 plus m2 x1 divided by m1 plus m2. X is m1 x2 plus m2 x1 divided by m1 plus m2. This is x coordinate, and y can be found m1 y2 plus m2 y1 divided by m1 plus m2. So instead of x, we are replacing with y. m1 y2 plus m2 y1 divided by m1 plus m2. So you are going to get the coordinates x and y whenever this ratio is given 2:3, 3:4, 1:2, and so on. So this is section formula. Third is midpoint formula used to find midpoint coordinates. It's actually derived from this only. So if you are having A and B, coordinates of A is x1, y1, coordinates of B is x2, y2. If I want to find out what is the coordinate of midpoint, I just have to use x is x1 plus x2 by 2 and y is y1 plus y2 by 2. Okay, add x1, x2 divided by 2 and m1, y is y1 plus y2 by 2. The reason is simple because the ratio is 1:1. So when I'm putting instead of m1 and m2, 1 and 1, so it's obsolete. Only x2 and x1 remain, and denominator 1 plus 1 will become 2. So that's why x is x1 plus x2 by 2 and y will become y1 plus y2 by 2. Area of triangle, there was a formula that's deleted, so no need to do it. But some books are still giving those questions, no need to do this. So we have only these formulas: distance formula, section formula, and midpoint formula. And in case centroid is asked, okay, though it was in the optional earlier, the same formula of midpoint can be used here in a different way. Centroid is the point of intersection of the medians. So x is x1 plus x2 plus x3 by 3 and y is y1 plus y2 plus y3 by 3. This is the coordinate of the centroid. And what is centroid? Point of intersection of the median. So in case this is asked that there is a triangle and you have to find out the coordinates of the centroid, then we will use this. It's not, as far as I think, it will not come, but still I am just giving you because it is very closely related to the midpoint formula. Now we come to trigonometry. This has got a little bit formulas. So trigonometry, chapter 8. Chapter 8 is trigonometry, coming from three words: trigonometry, three, gono, sided, metry comes from metron, which is measurement. So three-sided measurement. So basically in this we are looking at right angle triangles. And when we are having right angle triangles, the first exercise is dealing with 6 fundamental ratios. Which are the 6 ratios? Sine, cos, and tan. These are the basic ones, the fundamental ones, and the derived ones are the reciprocals: cosec, sec, and cot. Okay, so sine, cos, tan, these are the 3 basic trigonometric ratios. And once we know this, then these are the 3 derived ones. So here, if this is theta, theta is the unknown angle. Theta can be taken here or here. This is 90, this is fixed. Theta is the unknown angle. When you're taking this as theta, then this becomes the base, this becomes the perpendicular, and this becomes the hypotenuse. Or alternatively, the base is the adjacent side, and this is the opposite side, and hypotenuse is same, right? So I will explain both, because in some schools they teach perpendicular base hypotenuse, and in some they will teach you opposite side adjacent side hypotenuse. Okay, so why they teach opposite adjacent is because that's the correct way, actually, because opposite side is always opposite to the theta, whereas perpendicular and base will change depending on the theta that you take. So if you're taking an angle here, this is the base, this is the perpendicular, but opposite side is always opposite to theta. and this is the base. This is the adjacent side, always adjacent to theta. Okay. So sine is P by H, cos is B by H, tan is P by B. Sine is perpendicular by hypotenuse, cos is base by hypotenuse, tan is perpendicular by base. Or if I'm using the adjacent side and opposite side, I will use opposite side. I will use opposite side by hypotenuse. Cos is adjacent side by hypotenuse, and tan is opposite side by adjacent side. So there are two ways of remembering. If you are remembering this, then there is a short way of learning this. That is, some people have curly brown hair. Some people have curly brown hair, teeth polished black. If I am able to remember this mnemonic, some people have curly brown hair, teeth polished black. Just repeat that 3 times, you will get it. Some people have curly brown hair, teeth polished black. That's it. And you are able to learn of this formula because sine is perpendicular by hypotenuse, cos is base by hypotenuse, tan is perpendicular by base. The starting letters are here. Sine, P by H, cos, base by hypotenuse, tan perpendicular by base. If you are remembering the opposite side hypotenuse, then the simple technique is so ka tua. Just remember so ka tua. Sine is opposite side by hypotenuse, cos is adjacent side by hypotenuse, and tan is opposite side by adjacent side. So ka tua. So ka tua will take care of this. So you can do this. Now, once we learn of sine, cos, and tan, cosec is just the reciprocal of sine. So whatever values we have got here, we just have to reverse that. Sec is the reciprocal of cos. So whatever is the cos value, we will take the reciprocal, and cot is the reciprocal of tan. So easy. Once you know sine, cos, tan, cosec is the reciprocal of sine. So this is going to become hypotenuse by perpendicular or hypotenuse by opposite side. Sec is the reciprocal of cos, so that's going to be hypotenuse by base or hypotenuse by adjacent side. And cot is the reciprocal of tan, so this is going to become base by perpendicular or adjacent side by opposite side. So this takes care of our first exercise. The second exercise deals with angles. So I hope you got this. How to get this? Sine, cos, tan we get, and cosec, sec, and cot are basically reciprocals. Now for the next, you need to learn the values of 0, 30, 45, 60, and 90 for the 6 trigonometric ratios: sine, cos, tan, and then the reciprocals cosec, sec, and cot. Now there is a method to learn of this. So what we do is, before we start, we will just write here 0 by 4, 1 by 4, and root of all this, 2 by 4, okay, 3 by 4, and 4 by 4. So the easy 0, 30, 45, 60, 90 I've got, and I'm writing 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4. Now we just need to solve this, you will get this. So what am I going to do? I'm going to solve this. So 0 by anything is 0. So I'm going to write here 0. Root of 1 by 4, root 1 is 1, root 4 is 2, I'm going to get 1 by 2. 2 by 4, I'm going to cancel here, I'm going to get 1 and 2. So when I take a root of 1, I'm going to get 1, and root 2 will remain as it is. So 2 by 4, I'm cancelling, I get 1 by 2, root 1 is 1, and root 2 as it is. 3 by 4 root will become root 3, and root 4 is 2. So this is root 3 by 2. 4 and 4 will get cancelled, we get 1. So this is the most important thing to get our sign correctly. If our sign is correct, then only our table will be right. Otherwise, what will happen? There will be problems in our table. Okay, so we are going to create this table, and here you have to double check whether this is correct. Now, once this is correct, then cos is just the reverse order of sine. So once I know this, I'll put here 1. Okay, the last becomes the first. Here the root 3 by 2 I will write here. Root 3 by 2 I'm going to write here. Root 3 by 2. Then comes 1 by root 2. So sine 45 and cos 45 is same. This can come in the exam. Which value of theta, sine and cos are equal? The answer is 45. Then I have 1 by 2 here. I am coming here and 0. So what I have done, I have just reversed this order. So 0 to 1 and this is 1 to 0. Sine theta increases from 0 to 90. Cos theta decreases from 1 to 0. So whichever values you got, you are writing 1 root 3 by 2, 1 by root 2, half and 0. Now tan can be obtained by dividing sine and cos. Remember that. Tan is sine upon cos. When you divide this 0 by 1, you are going to get 0. Divide 1 by 2 and root 3 by 2. 2 and 2 gets cancelled. We get 1 by root 3. These are same quantities. When you divide same quantities, you will get 1. Root 3 by 2 by 1 by 2. 2 and 2 gets cancelled. We get 1 by root 3. And 1 by 0 is not defined. Not defined or infinity. Okay. 1 by 0 is not defined. Remember that. Then we come to cosec. Now these are all reciprocals. In the previous exercise, we've already done that cosec is the reciprocal of sine, isn't it? So when I take reciprocal of 0, 1 by 0, that is not defined or infinite. 1 by 2 reciprocal will become 2 by 1, that is 2. 1 by root 2 will become root 2. Root 3 by 2 will become 2 by root 3. And reciprocal of 1 is 1 itself. Okay, so cosec was, once you find, that's why I said, take out sine properly because these are all reciprocals now. Cosec is the reciprocal of sine. Sec is the reciprocal of cos. So if I found out cos correctly, my sec will be correct because all I have to do is take reciprocals here. So 1 will become 1 reciprocal. Root 3 by 2 will become 2 by root 3. Then 1 by root 2 will become root 2. 1 by 2 will become 2. And 1 by 0 is again not defined, that is infinite. Cot is the reciprocal of tan. So I've got tan here. So 1 by 0 is not defined, that is infinite. 1 by root 3, reciprocal is root 3. Reciprocal of 1 is 1. Root 3 is root 3 by 1. So when I take the reciprocal, I get 1 by root 3. And very important here, 1 by 0 reciprocal is 0 by 1, which is 0. Okay, 0 by anything is 0. So don't get confused between 1 by 0 and 0 by 1. So this is how we make the table. You need to practice this at least 2 to 3 times independently. You can understand how it is made. I'm sure you understood. Otherwise, you can replay the video and see how it is done and then try to make it on your own because these values will not be given to you in the exam. You have to make it on your own. And then we have the identities. So we have 3 identities. The first one, sine square theta plus cos square theta is 1. So from this, 1 minus sine square is cos square and 1 minus cos square is sine square. They're all same thing, just we have rearranged. So this is our basic identity, sine square plus cos square is 1. So I'll transfer sine square here, I'll get 1 minus sine square is cos square. Or I'll transfer cos square here, I'll get 1 minus cos square is sine square. This is first identity. Second identity is sec square theta minus tan square theta is 1. Sec square theta minus tan square theta is 1. So from here I can get, okay, these are all same things. Sec square theta can be written as 1 plus tan square theta. Or I can bring tan square this side. I will get tan square is, bring the 1 to the left. I will get tan square is sec square minus 1. Tan square is sec square theta minus 1. Third, I will get cosec square theta minus cot square theta is 1. So from here, I am going to get again 2 variations. What is the first one? Cosec square theta is, bring minus cot square that side, 1 plus cot square theta. Or you can also say, I'll bring cot square to the right side, bring the 1 to the left. Cot square theta is cosec square theta minus 1. So if I'm able to remember that sine square plus cos square is 1, sec square minus tan square is 1, cosec square minus cot square is 1, I will be able to derive all this. So this is what you have to know in trigonometry, and this is an important chapter as far as boards are concerned. Chapter number 9, some application of trigonometry. There is nothing new. Whatever you did in chapter 8, same formulas will be used. We use sine, cos and tan, more of tan. So tan values you should know. Tan 30, tan 45, tan 60. These values, it's better that you memorize so that you save time because the maximum questions are based on tan and 0 and 90 is not there obviously. Tan 30, 1 by root 3, tan 45 is 1, tan 60 root 3. These values you should know. So you had done this table, that is okay. But when we are doing applications, we are using only sine, cos and tan, and mainly the values of tan, 30, 45 and 60. So these three values you should memorize so that you don't waste time at all. So tan 30 1 by root 3, tan 45 1, tan 60 root 3. Rest of the formulas remain as it is. What you've done in sine, cos, tan, the same formulas we'll be using. No additional formulas here. Next we come to the circles chapter. Again, no formulas, but again, two theorems are there, very important theorems. Again, the first theorem that is given, angle between radius and tangent at the point of contact is 90. Whenever we are having the radius, this is the radius here, this is the tangent. What is a tangent? A tangent is a line which touches the circle externally at one point. This point is called the point of contact, isn't it? This is called the point of contact. This is the tangent, which is a line which touches the circle externally at one point. The theorem says that angle between radius and tangent at the point of contact is 90. And once it is 90, if I consider this triangle, it becomes a right angle triangle, and you can use Pythagoras in so many questions that you are supposed to solve. This will be used, right? So here we have this first theorem, and the second theorem, tangents from the same external point to circle are equal. This is the second theorem that you have to do. Tangents from the same external point to circle are equal. So if you are having a circle, we can draw from this point P two tangents, PA and PB, and according to the theorem, they will be equal. You can just join this and prove the triangles congruent. These two are equal by radius, and just now we did the theorem that angle between radius and tangent is 90. So this is 90, and OP is common. So right angle, hypotenuse side, triangles will be congruent by RHS, therefore PQ equal to PR CPCT. So there is no formula as such, but these two theorems you need to do in this chapter of circles. Then we have areas related to circles. This has got about a few formulas. Let's areas related to circles. Chapter number 11. Areas related to circles. So the basic formulas you should be aware. First of all, area of a circle. Area of a circle is, you've done from class 8 onwards, pi r square. Circumference of a circle, circumference or the perimeter of the circle is 2 pi r. If you divide the circle into two parts, then that is called a semicircle. So area of semicircle will obviously be half of a circle, pi r square by 2. If I divide the circle into 4 parts, equal parts, each part is called a quadrant. Area of quadrant will be 1 by 4 pi r square. Area of the quadrant will be 1/4 of a circle, that is 1 by 4 pi r square, right? Then we have important, this is already done in the previous. Now some important concepts are there. One is the concept of a sector. So if I am going to take a circle, and if I am going to look at this portion here, this is called a sector. And this is called a minor sector. This is the smaller portion. And you have this bigger portion that is a major sector. The angle here is theta. Now, what is area of a sector? This you may not have done earlier. Area of sector is pi r square theta by 360. This is the formula to find area of sector. Whether it is minor sector or major sector, formula is same. The only thing is that the value of theta will change. So suppose this angle is 80. Here, this will not be 80, this will be 360 minus 80. The reflex angle has to be found, right? So here the angle will be 280. So you are using pi r square theta by 360 here. Here also pi r square theta, but here you will have to use a different value of theta because we are not considering this angle, we are considering this. So this is the minor sector, major sector. So area of sector is pi r square theta by 360, right? So area of circle, circumference of circle, area of semicircle, area of quadrant. And this is area of sector. And there's another formula, half L into R. L stands for the length of the arc. So if you look at AB, that is an arc. So L stands for length of the arc. So some question, length of the arc is given. then you can use half L into R. R stands for radius. If length of the arc needs to be found, then length of the arc can also be found by using the formula pi r theta by 180. Okay, so area of sector, there are two formulas, pi r square theta by 360, or we can use half LR. And if length of the arc is unknown, we can use pi r theta by 180 to find out the length of the arc. And length of the arc is what? The distance from A to B. Okay, so this distance is called length of the arc. So pi r theta by 180, length of the arc. Then we have segment. Now this is again something new for many of you. This is called a segment. This part is called a minor segment, and this part is called a major segment. To find the area of the minor segment, we have to take the area of the sector and subtract this triangle. So, area of minor segment, if it is not specified in the question which segment, then it is always minor segment. Remember that. So, area of the segment is this sector, full sector, pi r square theta by 360 minus area of the triangle here. Now, if it's a right angle triangle, I can use half base into height. If it's an equilateral triangle, root 3 side square by 4. So, depending on the angle, the area of triangle will change. So, there is a general formula, half r square sine theta. Using this, you can find the area of any triangle. So area of minor segment is area of the sector, pi r square theta by 360, minus the area of the triangle, and area of the triangle is half r square sine theta. And you have done trigonometry, so you will get those values only. Like sine 30 is 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 91. And in some questions, they will give you sine 120. Now remember, sine 120 can be written as 90 plus 30. So this is actually cos 30. Okay, cos 30 is sine 90 plus theta. Formula is cos theta. It will become root 3 by 2. So you need not know all these derivations. But what you can do is, in case 120 comes, use root 3 by 2. So sine 1, because other values you have already done in trigonometry, 120 you may get stuck. So if it is 120, use root 3 by 2 as the value here. Radius value will be given. You can find area of the minor segment. And area of major segment, area of major segment will be area of the full circle, that is pi r square, minus area of the minor segment. Area of minor segment. So if I want to find area of major segment, I will first find area of the minor segment and subtract it from the area of the circle. Area of the circle we know is pi r square. So area of the major segment will be pi r square minus area of minor segment, which is already, I have given you the formula, pi r square theta by 360 minus half r square sine theta. Next we come to chapter number 12, surface area volume. Now in surface area volume, chapter number 12, surface area volume, we have cube, cuboid, sphere, hemisphere, cone and cylinder, 6 figures. Surface area and volume, and you have already done cube, cuboid, cylinder in the lower classes, and 9th you may have also done sphere and hemisphere and cones. So all the figures are same, repetitive. First term of cone is deleted. So let's go through the formulas. The first one is a cube. So we have 4 formulas. One is lateral surface area. Lateral means the 4 walls. The top and bottom is open. So lateral surface area is 4 side square. All the sides of the cube are equal, 4 side square. If the top and bottom is closed, then we use total surface area, TSA, 6 side square. 4 side square, open from top and bottom, total surface area, 6 side square, closed box. Third is volume. Volume can be found by using side cube. And diagonal of a cube can be found by using root 3 side. So we have 4 formulas for cube. You can note down. Then we have cuboids. In cuboid, unlike the cube which has got all sides same, we have 3 dimensions, length, breadth and height. The lateral surface area or the area of the 4 walls. Okay, you want to whitewash the walls and so on. 2HL plus B, area of four walls or lateral surface area. Total surface area is 2 bracket LB plus BH plus HL. Volume of cuboid is LBH and diagonal of a cuboid is root L square plus B square plus H square. Now, sometimes they say that find the longest rod that can be placed in a cuboidal room. The longest rod is the diagonal. There's nothing longer than a diagonal, one corner to the other. So we will use this diagonal of cube root L square plus B square plus H square. After cube and cuboid, the next figure that we will discuss is cylinder. Cylinder, we have curved surface area. Okay, this is curved, so we use curved surface area. This is not curved, so we use lateral. This is also lateral, but we'll use curved for this. You can use lateral or curved for this, but you cannot use curved for cube and cuboid because the surfaces are not curved. So curved surface area is 2 pi RH for cylinder. Total surface area is 2 pi R plus H. Curved surface area means the two circles are open. The top and bottom are open. Here the top and bottom is closed and TSA. Volume is pi R square H. And that's it. So 3 formulas only we have to do in cylinders. CSA, TSA and volume. Then we have cones. In cone, we have the radius, height and slant height. Now this is called slant height. The slant height is greater than the height because this is a right angle triangle. So slant height is the hypotenuse, it will be greater. So in case in some questions slant height is not given, we can find that out by using Pythagoras. L square equal to H square plus R square. Out of the 3, if any 2 are given, we can find out the third. Curved surface area is pi RL if the cone is open, pi RL. Total surface area if the cone is closed, pi R plus L. And volume of a cone is 1/3 of a cylinder. Cylinder was pi R square H. This is 1/3 pi R square H. Then we come to the next figure, that is sphere. Sphere is a 3-dimensional figure. Although I'm drawing it like a circle, it's like a football or earth sphere. It doesn't have CSA, TSA. It's not open at all. It's closed. So we have surface area 4 pi R square and volume is 4/3 pi R cube. Only 2 formulas for sphere, area and volume. Direct 4 pi R square, 4/3 pi R cube. If I divide this into 2 equal parts, each part is called a hemisphere. Each part is called a hemisphere. Curved surface area is half of this. So the full was 4 pi R square. Now it is 2 pi R square. Total surface area is 2 pi R square plus pi R square on top. It's closed. So that will become 3 pi R square. And volume is half of the sphere. This is 4/3 pi R cube. This will be 2/3 pi R cube. So these are the formulas of this chapter. So we have 6 figures, cube, cuboid, cylinder, cone, sphere, hemisphere. These are the formulas that you have to learn from this chapter. Now we come to statistics, chapter number 13, statistics. Here we have mean, median and mode. So when we talk about mean, that is the average. Mean is the average. If it is raw data, then formula is sum of observations divided by number of observations. So raw data means you will get random numbers like this and you have to find the mean of this. So what you need to do is so sum of observation, I'll add all these numbers 3 plus 4, 7, 12, 18 and divided by the number of observation, that is 4. So I'm going to get the answer 4.5. Add all the numbers and divide by the number of observation. This is for raw data, right? If it is not raw data and if it is in the form of class intervals and frequencies, then there are 3 methods given to us in the book. One is the direct method. In direct method, the mean formula is sigma fi xi by sigma fi. Then we have the assumed mean method. assumed mean method. So mean is A plus sigma Fi ui by sigma Fi into H. And then we have the step deviation method. That is mean is equal to A plus sigma Fi ui by sigma Fi into H. So there are three different methods. If you are not aware, then please watch the video on statistics, which is available on the channel. You will be able to understand how the three methods are. Right now, I am discussing only the formulas. So direct method, we will use sigma Fi xi by sigma Fi. Assume mean method, A plus sigma Fi ui by sigma Fi into H. And step deviation, A plus, okay, assume mean method, one correction, sorry, sigma. This is step deviation method. In the assume mean method, I am going to use A plus sigma Fi di by sigma Fi. Sorry for the correction has to be made. This is the step deviation, A plus sigma Fi ui by sigma Fi into H. Assume mean method, we will use A plus sigma Fi di by sigma Fi. Please note the correction. In assume mean method, we will use this A plus sigma Fi di by sigma Fi. And as I told, if you're not aware of these methods, you need to watch the statistics chapter, how it is done. Next, we go to the mode and medians, right? So, how do you find mode? Formula for mode is L plus F1 minus F0 to F1 minus F0 minus F2 into H, where L is the lower limit of the model class. F1 was the highest frequency and F0 is the frequency above that and F2 is the frequency below. Again, as I told, if you do not know how to do this, kindly refer to the channel and watch the recording. And median is again formula L plus N by 2 minus CF by F into H. So this is the formula for finding mode and this is the formula to find median. So that is mode one formula, median one formula, and mean we have three formulas. Then the last chapter is probability. In probability, there is only one formula. Probability of an event is number of favorable outcomes. What is favorable to us? Favorable outcomes divided by total outcomes. This is one formula that you have to do in this chapter. That's it. And one thing that you have to remember is that whenever there is a sure event, the probability is 1. Probability of an impossible event is 0. And therefore, all answers of probability will be greater than equal to 0 and less than equal to 1. Nothing should be below 0. Nothing should be more than 1. Every answer of probability should lie between 0 and 1. So here the question based on coins, question based on dice, question based on random picking of numbers, question based on cards. These are all important. Then leap year, non-leap year questions. You can go through those questions. It's a very easy exercise, but there is only one formula. P is number of favorable outcomes by total outcomes. So I have discussed all the formulas of all the 14 chapters. I hope this is going to be a good revision for you. If you do not know any formula, please write and practice. That's important. Thank you and all the best.